Welcome to our channel. Today, we're tackling the big questions. Why does the weather do what it does? From the science of snowflakes to the chaos of hurricanes and the sweltering heat of the tropics, this episode of Tell Me Why will blow your mind. Join us as we delve into 10 shocking weather facts that you may never have known. Get ready to be amazed because some of these facts might just blow you away. Tell me why some places never see snow. Imagine a world where children grow up never having seen a snowflake, where the ground never wears a blanket of pristine white. Believe it or not, such places exist. In certain regions of our planet, snow is a foreign concept. Take, for instance, the lush rainforest near the equator. These tropical havens, teeming with life, are far too warm to ever experience the magic of snow. Snow formation requires a delicate balance of freezing temperatures and moisture, but in places like the Amazon rainforest, the mercury rarely dips below freezing, making snow formation an impossibility. Tell me why hail forms during thunderstorms. From the serene absence of snow, we turn now to a far more dramatic weather phenomenon, hail. These icy spheres, ranging in size from tiny pebbles to grapefruit-sized projectiles, are a testament to the raw power of thunderstorms. Inside a towering thundercloud, powerful updrafts and downdrafts rage, creating a chaotic ballet of wind and water. Raindrops, caught in these powerful updrafts, are carried high into the atmosphere, where temperatures plummet below freezing. As these supercooled water droplets collide with ice crystals, they freeze on contact, forming hailstones. This cycle continues until the hailstones become too heavy for the updrafts to support, and they plummet to the earth, sometimes with destructive force. Tell me why snowflakes have 6 sides. While hailstones are a testament to the brute force of nature, snowflakes reveal a more delicate and intricate side to frozen precipitation. Each snowflake, a unique and ephemeral work of art, is a testament to the elegant order that underlies the seemingly chaotic world of weather. At the heart of every snowflake lies a single ice crystal, a tiny hexagon formed by the unique molecular structure of water. As this ice crystal falls through the atmosphere, it encounters supercooled water droplets, which freeze on contact. Water molecules, attracted to these points, attach themselves in a symmetrical pattern, creating the 6-sided structure characteristic of all snowflakes. Temperature, humidity, and even the presence of dust particles can all influence the intricate patterns that adorn each snowflake. Tell me why tropical regions are hotter than polar regions. Our journey through the wonders of weather now takes us from the microscopic world of snowflakes to the global scale, as we explore the stark temperature differences between the Earth's tropical and polar regions. The equator, that imaginary line circling the Earth's waistline, is bathed in the sun's most direct rays. This intense solar radiation heats the tropics, creating a band of consistently warm temperatures that encircle the globe. In contrast, the Earth's poles, located at the top and bottom of our planet, receive sunlight at a much lower angle. The result is a stark contrast in temperatures, with the tropics basking in year-round warmth while the poles remain locked in a deep freeze. Tell me why it's more humid near the ocean. Have you ever noticed how the air feels heavier and stickier near the ocean? This palpable difference in humidity is a direct result of the ocean's constant interaction with the atmosphere. The vast expanse of the ocean acts like a giant humidifier, constantly releasing water vapor into the air through evaporation. As the sun's rays warm the surface of the ocean, water molecules gain enough energy to break free from their liquid bonds and become water vapor, a gas. This water vapor, lighter than air, rises into the atmosphere, increasing the amount of moisture in the air. Coastal regions, therefore, tend to experience higher humidity levels than inland areas. Tell me why some winters are colder than others. While the tropics enjoy relatively stable temperatures year-round, those of us living in temperate regions know that winter can be a fickle and unpredictable season. Some winters are mild and short-lived, while others seem to drag on forever, bringing with them relentless cold and snow. This variability in winter weather is due to a complex interplay of factors, including atmospheric circulation patterns, ocean currents, and even the whims of the jet stream. One of the most significant drivers of winter weather is a climate pattern known as La Niña. During a La Niña event, the surface waters of the Central and Eastern Pacific Ocean cool down, which can have ripple effects on weather patterns across the globe. For many parts of the world, including North America, La Niña winters tend to be colder and snowier than average. Tell me why tornadoes are more common in certain areas. From the icy grip of winter, we journey now to the heartland of America, a region where the skies can unleash a far more violent and destructive weather phenomenon. The tornado. Tornadoes, those rapidly rotating columns of air that extend from thunderstorms to the ground, are a terrifying force of nature. While tornadoes can occur almost anywhere in the world, they are most common in a region of the United States known as Tornado Alley. This corridor, stretching from Texas north to South Dakota, has the unfortunate distinction of experiencing the perfect storm of conditions for tornado formation. Warm, moist air from the Gulf of Mexico collides with cool, dry air from the Rocky Mountains, creating an unstable atmosphere ripe for severe thunderstorms. Add to this mix strong winds, which can cause the updrafts within thunderstorms to rotate, and you have all the ingredients for a tornado outbreak. Tell me why deserts can have flash floods. When we think of deserts, images of scorching sun, endless sand dunes, and parched landscapes typically spring to mind. But these arid environments, often starved for moisture, can transform in the blink of an eye into raging torrents of water during a flash flood. The key to this dramatic transformation lies in the unique properties of desert soil. Unlike the absorbent soils found in many other ecosystems, desert soils are often compacted and dry with a crusty surface layer that prevents water from easily penetrating. When heavy rain falls on this unforgiving terrain, the water has nowhere to go. Instead of soaking into the ground, it runs off rapidly, accumulating in dry stream beds and gullies, transforming them into raging rivers in a matter of minutes. Tell me why climate change is making weather more extreme. Our exploration of weather's extremes brings us now to a sobering reality. Our planet's climate is changing, and these changes are having a profound impact on weather patterns around the globe. The Earth's climate is a complex and interconnected system, driven by a delicate balance of incoming solar radiation and outgoing heat. Human activities, particularly the burning of fossil fuels, are releasing massive amounts of greenhouse gases into the atmosphere, upsetting this delicate balance. These greenhouse gases, acting like a blanket around the Earth, trap heat and cause the planet to warm. As global temperatures continue to rise, we can expect to see more frequent and intense heat waves, droughts, and wildfires. Tell me why it's colder at higher altitudes. For our final weather fact, we ascend to the lofty heights of mountains where the air grows thin and temperatures plummet. Here, in these rarefied environments, we encounter a fundamental principle of atmospheric science. The higher you go, the colder it gets. This inverse relationship between altitude and temperature is due to the decreasing air pressure at higher elevations. As we ascend, there is less atmosphere above us, so the air pressure decreases. At higher altitudes, where air pressure is lower, air molecules are more spread out, resulting in fewer collisions and lower temperatures. This is why mountaintops, even in tropical regions, can be capped with snow and ice year-round. From the snowless tropics to the hail-producing thunderstorms, from the delicate beauty of snowflakes to the destructive power of tornadoes, we've journeyed through a diverse array of weather phenomena, uncovering the science behind these awe-inspiring events. I hope you've enjoyed this exploration of our planet's remarkable weather. If you found these facts as fascinating as I do, please give this video a thumbs up. Subscribe to our channel and hit the notification bell so you don't miss out on future explorations. Thank you for joining us on this adventure into the heart of weather. Until next time, keep looking up at the skies with wonder and curiosity, and never stop exploring the natural world around us.